In this tutorial, we're going to demonstrate how to model and calculate the toolpaths for this two-sided chess piece that you can see here on screen. If you've never worked with a two-sided project before, I recommend that you watch the Getting Started two-sided machining tutorial before continuing with this project. First thing we're going to need to do is to create a new file. So let's go ahead and click on that. So this is going to be a double-sided job, and we are going to set the width as being 2 inches and the height as being 6 inches. And the material thickness is going to be 1.75. And we are going to zero off our material surface, but we're also going to want to, when we flip over our material, zero off the machine bed for the second part. That way we're always referencing the top of our material. Now there's no right way of doing this. Just in this particular situation, this will work better for us. And so just depending on how you want to cut this part, you might want to switch this up. For us, this is the way we're going to go this time around. We're going to use our datum is going to be set to the bottom left-hand corner. We're going to flip left to right, so left to right. We're going to use a very high modeling resolution because we are going to create some brand new 3D content. We're going to want to make sure we have all the pixels that we can, and we'll just go with whatever the material setup is, and we'll click OK. For this project, instead of starting right from scratch, we're actually going to bring in a bitmap, a pencil drawing of the silhouette of the chess piece. So let's go up here to import in a bitmap. And we're going to bring in our king chess piece.png file. And this can be found in your tutorials folder. I'll just open that up. And you'll see that it gets imported directly into the center of our job space. So we're going to look at modeling this in two operations. One component will be for the rounded body, and the other component will be for the cross on the top, and they'll be merged together in the end. As we're creating a part that is going to be identical on both sides to form the full true 3D piece, we will look at creating all of the vectors and the components for the top side, and once we're happy, then we'll simply copy those over to the other side. And the software will automatically line this up based on how we chose to flip our job. In this case, we chose to flip it left to right. And we'll take a look at that a little bit later on just to be sure that we understand how that's going to work. To start off, let's go ahead and start to trace the cross on the top. Now, when we're drawing, we're going to make use of our smart snapping options. So both of those are turned on. We're also going to want to make sure that we adjust our snapping radius of our tool. And that can be found under Edit, Snap Options. And we're going to make sure that we look at our snapping radius. And we're going to turn that all the way down to 4. Okay? Then we can just click OK. Now the trick here is to draw only what we need. So we're only going to draw half of our cross, and then we're going to flip it over and then connect the two vectors together to make the full shape of the cross. Now with the cross, we're going to use our shape creation tool to create the cross, and then when we actually draw the half of our chess piece here, the body of it, we are going to use our turn function to turn that over, almost like on a lathe, where we're going to take a vector and we're going to spin it across the common center point or the common plane that our start point and end point share to give us that full rounded shape. And we'll take a look at that in just a second. So for now, we're just going to zoom in on the cross, and we're going to go over here and select our polyline. Now, as soon as we get close to the center of our job, you'll see that it snaps to the center of our job. Now, luckily, the bitmap that we imported in was pretty much the same size as our job space, so it's been cropped to fit almost in the center of our job pretty much right away. So we don't need to worry about messing around with that too much. Let's just go ahead and start drawing in some vectors here. Now, as we use our Polyline tool, we can drop in nodes where we'd like to, but if we decide that we'd like to jump right into creating a Bezier, all we need to do is just click and hold our button down, and you'll see I jump right into a Bezier to create a nice round bottom for that. Now this piece here will actually be tucked inside of this turn, so we're really not too worried about that, but that'll give us a good shape to work with. So let's right click on that. Now we're going to go into node mode, and we're going to take a quick look at all of these different spans here and try to make them a little bit nicer, kind of follow the shape that we have here and give us some nice corners to work with. So we're going to right click on this, and we're going to turn this into a Bezier. You can just kind of grab this and pull it up a little bit. Maybe we'll do the same for this one. Just puff it out a little bit. Maybe pull this one in a little bit to give it a shape like that. We can now go here, we can right click on this and we can smooth that out a little bit. Let's pull this down like that. Do the same for this one, right click and smooth that out. Pull that down. You'll see it snaps nice and a nice straight line there for me right away. That's great. I like that just the way it is. We'll right click and we'll turn this into a Bezier. And we can just kind of refatten that up a little bit. You pull it back. And if I want to check to see what it looks like, I can just right click off of that for a sec. That looks okay. Let's just kind of work on this area for a second. So let's reselect that. I'm going to grab that and just scoot it down a little bit. Same with this here. Maybe we'll scoot it up a little bit. There we go. I'm pretty happy with that. That's great. So let's just go ahead and right click out of that. And we'll just scroll down a little bit and zoom out just to the point where we can see the full body of our chess piece. Now again, what we're going to want to do is create a shape that the start point touches the center of our job, and same with the end point, so that when we turn this over, we're going to get a full half shape of the body of our chess piece. So let's just zoom in a bit here. We're going to go back to our Polyline tool. Just drop one there. Just going to drop in some points. We'll hold in our button to get us that shape. So with that, we can just use our scroller wheel to zoom out, and we can slide down. Now again, let's just hold that in and see if we can get a shape that looks okay. We can go back and edit that in a sec. If I want to go back to a straight line again, I can just press S on my keyboard and I'll pop back into a straight line again, so I can fix that later. And we'll just pop that on there. One down here, there, there, and there. We want to make sure we come right back to our center again, because when we turn this, it's going to be turned on the shared plane that we have our start and our end point sitting on. So we want to make sure that they're okay. Now let's go ahead and do some quick editing. So with that selected, go into node mode, that's N on your keyboard, and we're just going to go back here and we are going to kind of work away at shaping this just a little bit better. Right click on this, we'll turn that to a Bezier, snap that on there. Looks pretty good. Let's pull that handle up a little bit, give us a better shape there. That looks all right. Scoot down so it comes along. Let's just go ahead and right click on this, we'll turn it into an arc. That'll give us a nice shape for that. That looks really good. And we'll just grab those two and just use our cursor keys and drag them up. Now this fella right here looks a little funny, so let's see if we can make it look a little bit better. Let's right click here and we're going to insert a point, and then we can just grab that point and pull it out there. Straighten this out a little bit. That looks okay. Turn that down here a little. Yeah, that's perfect. I like that. Scroll down a bit. Now we need to right click on this, turn this into a Bezier. Just kind of guide that in a little bit. Let's do the same here. Now instead of us always right clicking, I could have just pressed B on the keyboard and that would have helped me. Now this here comes to a really sharp point. So let's just go ahead and insert in a node here. So I'm going to press I on my keyboard, just hovering over where I want that point to go. We'll insert one here as well. We're going to hover over top of that and press D on our keyboard to delete it. And we're just going to use these control handles just to kind of give that a nicer shape. That looks better. This here as well, we'll just pull you down. And let's turn this into a Bezier. Give that a bit of a rounded tip. I like that nice sharp inside angle there. We'll give that a nice sharp angle. And I think overall that looks pretty good. So let's press F on our keyboard to fit that to our screen. Let's right click to unselect that. And let's go back to our selection mode for a second. Now that we have our vectors drawn, let's go ahead and start to model the top side of our chess piece. So to do that, we're going to go to our modeling tab. And as I mentioned earlier, we're going to use this function right here, which is called create a shape by spinning or turning a vector. So we're going to choose this vector right here, and we're going to go ahead and choose that option. So we're going to go ahead and choose the first option here, which is going to be the turn function. We're going to make sure that we don't scale this to an exact height. We're going to merge this in, and we're going to name this King Chess Piece. And then we can go ahead and hit apply. Now let's go ahead and tile our view so we can see both sides of just what happened. So like I had mentioned, we've taken that line and we've turned it around the shared plane that we have, and we end up having this half of a king piece, and that looks really good. That's exactly what I was hoping for. Really like that a lot. So let's look back down on that again, and we can close this down. Now with that particular piece selected, let's have a look at the component properties for us, just to make sure that it fits with inside of our material block. So at the top we have the name, King Chess Piece. Of course we could change that if we wanted to. Now at this point it's a merge component, and the shape height that we have in the end is 0.7666. Now that is the thickest part of this vector. So the distance from here to the top point of this vector is 0.7666 thick. So when we turned it, then the top of this is actually that exact height, and that will fit into our 1.75 inch material block without any trouble at all, especially when we double that, because we're going to need both sides. So just go ahead and close that. And now we're going to look at creating the cross at the top here. Now in order to do that, we are going to use our shape creation tool, but in order to use that shape creation tool, we need to have a closed vector, and right now we just have half of that vector. So with that selected, we have a couple options. We can use our mirror selected objects across the center point. Then we could join that together to make a closed vector. Or what I can do is I can hold down my Control, my Shift, and my H key. So it's Control to copy, Shift is across a center plane, and H is the horizontal plane. And as soon as I touch that, you'll see now I get a copy of that. Holding down my Shift key, I can select both of those, and I can go over to my Drawing tab and choose to join those together. And you'll see that I have two open spans. If the start and end points are within a tolerance of 0.004 of an inch, then it will close those. And in the end, it's going to give me one closed vector after joining things together. That's perfect. Let's click join and close this down. And now we have that one continuous vector here that's closed at the end. Let's go back to our modeling tab. Let's go ahead and create that shape. Now what we're going to do is we are going to use an angular profile. We're going to select that, and we're going to set this to be 45 degrees. We're going to give this a base height of 0.1, and then we're going to limit our height to 0.01. So this will give us a shape that has a slight base height, has a bit of a chamfer on the top of it, and then will taper out and be flat on the top. We're going to make sure that we merge this into our job, and we're going to call this cross. And then we can click apply and see what happens. And you'll see that in our 3D view now we have a nice cross on top of our chess piece. And that looks really great. Let's close that down. Now in order to keep our job all organized, we're going to rename this level to models. So let's go ahead and rename that level by right clicking on it and choosing rename. And we're going to change this to models. Now this will be important because later on we'll be referring to this level when it comes to actually cutting our parts. We're going to want to keep this as organized as we can, so in the end it makes it a little bit easier to create the tooling for this particular part. Okay, now that we have this all set up, we've got our front of our chess piece and the front of our cross all done and all merged in properly. Now we can go ahead and start thinking about how we're going to machine this. So there's two things we need to take into consideration here. One is how are we going to secure this into our material block? And second is how are we going to index this and locate it properly on our CNC so that the front and the back will line up. So the first thing, let's talk about securing this into our material block. So to do that, we're going to need to add in some tabs. And for that, we're going to use some 3D tabs. So let's go over here to our component tree and let's right click on our models level, and we're going to insert in a new level, and we're going to right click on that. We're going to rename that tabs. And this is where we're going to put all of our tabs. And because we want to make sure that our tabs merge in with our finished chess piece here, we're going to right click on that tabs level again, and we're going to change the combine mode to be merge. Now anything that falls on that will end up merging in with our composite model of our chess piece. Now let's go ahead and look at our clip art tab. And now if you've chosen to download all of the free clip art that comes along with your software, you would have been given a set of 3D tabs. And we're going to look for a tab that's called underscore rectangle in your list of tabs. So we're going to go ahead and double click on that, and it will be brought directly into the center of your job. So let's just move that out of the way for a second so we can talk about this. So right off the bat, you're going to know or notice that that tab is really way too big for what we need. We want a tab that's going to fit into the right-hand side of our cross and the left-hand side of our cross, and then also into the bottom of our chess piece here in 2 different spots. So let's rotate this around first of all to get the orientation correct. So with it selected, just press 9 on your keyboard twice. And then we're going to go over to our modeling tab, and we're going to go down to set size. And we're going to scale the selection. We're going to use the job alignment box. The center anchor point's fine. The width we're going to leave the way it is. We're going to make sure that our link X and Y is turned on and our auto Z scale is turned on. And we're going to change this to be 0.18. And then we're going to click apply. And then we'll close this down. Now what we can do is we can grab that tab and we can move it over in place where it belongs. Right around there. It's perfect. Now let's check the shape height of this to make sure that it's thick enough to do the job. There are a couple different ways we could do this. We could go over to our modeling tab into our component properties and choose to do it from there. Or what we could do is just click on this little blue box here to bring up our floating properties dialog in the 3D view. Let's click on this and you'll see that the shape height right now is 0.0891, and that's pretty good. We're just going to round it up to 0.9 for some easy math so that we can, in our head, we know that when we add the tab to the other side that we're going to be doubling this up. So 0.18 of an inch for a tab is going to be perfect to hold this part into place. Let's close that down. And now what we want to do is add in the other tabs that we need. And to do that, we can just drag this by holding down our control key and we'll make a copy over here. If we hold down our Alt key, it will just lock it into that vertical plane. And now if we go down here, we'll hold down our control key again and we'll drag it to the bottom. Let go of it there and we'll press 9 on our keyboard again and turn it around and use our cursor keys to nudge it into place. Then holding down our Control, Shift, and our H key, that's Control to make a copy, Shift across the plane, and H being the plane we want it to flip it across, we can go ahead and make a copy of that across the bottom. And now you'll see we have 2 different tabs at the bottom holding into place down there. And that looks really good. Also, you'll notice that we had the tabs level selected. So when we brought in the first rectangular tab, that got plunked onto that level. And then the copies that we made all went onto that level the way they are. So we can hide and show those tabs. And there we have it. To keep the material aligned in the X, Y, when we flip the material over, I'm going to look at using the non-symmetrical dowel hole method. This is where we would drill holes partially through the top side of our material, and then in the software we would copy the dowel positions from the top side over to the bottom side. We will cut the holes for the bottom side directly into the spoil board, allowing us to have perfect alignment in the XY when we flip the material block over and push it onto the dowels. Now there are many other methods that we could use, but I know this method is fail-safe because there's only one way our material will fit when we flip it over. This eliminates the fact that we might flip the part in the wrong direction to what we have told the software. Okay, now I've gone into our labs and I've measured a dowel and they are about 0.33 of an inch in diameter. So if I go to my drawing tab and we go to our circle and I choose to make a circle with a diameter of 0.33, I can just click anywhere in my 2D view and drop in some circles. Now I'm going to put in 3. That will ensure that there's no way that I can mistakenly turn this the wrong way and have everything line up. So that's a great way of doing it. So let's close that down. And we're ready now to move on. So the next thing we need to do is copy all of this to the other side of our job. So we're going to select everything. Then we're going to right click on it and we're going to say copy to other side. And nothing has changed until we go ahead now and flip over to the other side of our job. And you'll see that it looks pretty much the same if we flip back and forth, but you'll see that the software has flipped the dowel holes over so that when we flip our material left to right, then those dowel holes will match up when we cut them into our spoil board, when we use the ones from the back side to create our tooling for those spoil board dowel holes. And so that looks pretty neat. Now, another thing that's kind of interesting is that we have over here turned on our double-sided view. So if we go ahead and rotate our job, we can now see both sides of our chess piece, where before we could only see one. Now, if I wanted to get rid of this hazy modeling plane here just to get a nice clear view, I can go up to View and I can turn off Draw Modeling Plane. And you'll see that I can see that full chess piece as it should look when it comes out of my material block in the end. Let's look straight back down on that again. Now, if we go to our Modeling tab and we look at our second side, you'll see that although we copied all of these components over to the other side, it hasn't created the proper levels for us. So let's just go ahead and redo that. So for now, let's just right click on that and we're going to rename this Models. And we're going to add in a new tab, or add in a new level, and we're going to call this one Tabs. Now what we can do is just select these tabs and we can move those, holding down our Shift key, we can move those onto the tabs layer by dragging them. And there we have it. Now it's set up right with everything where it should be, so I can hide and show those tabs. Flip this over to be a combined mode of merge, and so now they're merging in properly in the 3D view like they should be. So there we go. Let's look straight down on that again. Let's go back to our top again. And let's take a second and think about how we're going to cut out this chess piece. Okay, before we get started, let's go ahead and turn off our multi-sided view. And let's go back over here and turn back on our modeling plane. And then we're going to maximize our 3D view and we're going to look at it from the side. And this will help us better understand the next part of the process. We are going to be using some 3D tooling for our roughing and our finishing pass. And for our finishing pass, we're going to be using a 1/8 inch ball nose end mill. So it has a round end to it. And what that will do is as it comes down the side of our chess piece, as it comes to the modeling plane, it won't go past that because there's nothing by it. It will stop there. We'll end up having a little cusp, and a little cusp almost looks like a little piece of a hand carving left behind. And what that will do is it will leave a seam all around the top and the bottom of our part that we're going to have to remove somehow in the finishing steps. But we can get rid of that, or at least help minimize that anyway, by telling the software or making the software go past that by using a limit plane. And so to do that, we are going to set up a new level. We're going to put on that level a 0 plane, and we are going to give that a negative base height in order to drop it down so that we can make the tool go past the edge of our model. And we're going to call that distance the overcut distance to that 0 plane, which will now be called our limiting plane, and stop it there. And that'll make more sense in just 1 second. So let's go over here to our component tree. Let's right click on that. And we're going to insert a new level. Right click on that and we're going to rename that. And we're going to call this limit plane. And we're going to turn this into a combined mode. It's going to be a merge, because if we go ahead and add a negative 0 plane or any negatives component to this and we add it in, then it's going to end up dropping the whole thing down, and we don't want to do that. We want to leave our chess piece right where it is, and we're going to add in a 0 plane, and you'll see that it shows up here in our 3D view, but it has literally no height to it at all. It's just there right now. But if we click on it and we go up here to our object properties or component properties, we can give it a negative base height, and we're going to make this the radius of our tool that we're going to use for our finishing. So it's going to be a 1/8 inch, so half of that is a 1/16. So we're going to put in 1 divided by 16 and press equals on our keyboard, and then we're going to make sure we put a negative sign in there. That way it'll drop it down and not up. And then you'll see in our 3D view, we now have our limit plane, our modeling plane, and then above that is the full thickness of our chess piece. We haven't dropped the whole chess piece down. We've just merged this in below the modeling plane. And that will help to limit that tool and give us that overcut distance that we need. Okay, so let's go straight back down on that again. We'll close this down. And now that I'm happy with that, we can go ahead and move on to our toolpathing. So let's pop over to our Toolpaths tab. Okay, to start off with, we're going to go ahead and tile our views so we can see both our 2D view and our 3D view. And then we're going to go ahead and create the tooling to cut our dowel holes in the top of our material block. So to do that, we're going to need to select all of those dowel holes. And we're going to choose to create a profile cut. We're going to have a start depth of 0. We're going to go down 0.7 of an inch. We're going to select a 1/4 inch end mill for this. And we'll go ahead and select that. We're going to cut on the inside of those holes. And we are just going to go ahead and name this dowel holes. And we're going to calculate that. And you'll see that in our 3D view, we have the dowel holes there, the toolpaths for them shown. And we can go ahead and preview that visible toolpath, and we'll see what we get in the end. That's great. Just close that down, look back on this again, and then we'll proceed to our roughing pass. So for our roughing pass, we're going to go ahead and use a 1/8 inch end mill. And we'll select that. And we have some different ways that we can limit our boundary or our toolpath boundary. We can use a model boundary, which will, in this case, encompass our 3D tabs, which wouldn't be very good for us because when we got done cutting this out, the part would fall out because we'd cut around the whole end of these tabs. So that's not a good idea. We could use our material boundary, but the same thing would happen. We'd have nothing holding this in place again. We could use selected vectors, but we don't have any vectors currently right now that profile around our whole chest part. But we could use selected level. Now, if you remember, over on our modeling tab, we were smart enough to put all of the important parts of our model on a level called models. So if we go over here and we choose level and we go models, that's the name of the level, then what the software will do is it will create a bounding box or a profile vector around the outside of this, and it will just contain the tooling within that or base it on that outline. We're going to put in a boundary offset of 1/8 of an inch. Put equals in there. We're going to leave a little bit of a machining allowance behind, so a little bit of material behind, so that we can get rid of that during our finishing pass. We'll use Z-level roughing, that's perfectly fine. And then we're going to go ahead and just call this 3D roughing, and then we'll calculate that. And then we can go ahead and preview that visible toolpath. And we'll see exactly what's happened here. We've cut that out. And again, we've limited our toolpath to the shape of the components or the composite model that was on that level. And that looks really great. So let's just go ahead and look back down on that again. That looks great. So let's go ahead and close this down. And now we're ready to do our finishing pass. So let's go ahead and do that. We're going to remove this 1/8 inch out of here. And then we are going to select a brand new tool. We're going to choose this 1/16 inch bullnose end mill. Let's select that. We're going to make sure that we choose the selected level option here like we did for the roughing pass. We'll drop this down and we'll choose models. Now we're going to go with a boundary offset of 1/16 of an inch. We'll make this raster tooling. We're going to make this 90 degrees. We'll do a finishing toolpath, rename that, and then we'll calculate that. Now let's go ahead and preview that visible toolpath, and you'll see we get a nice clean cut and everything looks great. If we zoom in a little bit, you'll see that cusping we were talking about, but that's happened past the side of our model, the center line, so it's past the center line, and that should be removed when we do our tooling for the second side. So let's go ahead and look down on that, and let's close that down. Okay, let's go ahead and start to think about creating the tooling for the other side of our part. So let's go over here and we're going to flip to the other side of our job. And we're going to check our material setup. Now we're just going to do this to reassure ourselves that everything is set up like we expect. So the thickness of our material is 1.75 inches. Our datum is set to the bottom left-hand corner. We are going to be zeroing off our machine bed for this side, not the material surface, so keep that in mind. That way we're always going to be zeroing off the same side of the material. Now this is going to be important because it will ensure that our part will fall exactly in our material where we expect it to be. We're not going to move our model position in the material. It's important that we leave this just as it is. Don't touch it. We're going to check our rapid Z gaps and make sure that they're safe and appropriate for our machine, and our home and start position are the way they should be. And if that's all okay, then we can just go ahead and click cancel. Now you may have noticed up here in our material setup that our home position now is X0, Y0, Z is 2.55 of an inch. That number comes from the thickness of our material plus our safe Z gap that we set up in our material setup that was 0.8 of an inch. So 1.75, that's our material thickness, plus the 0.8 equals 2.55. And again, we need to be sure that we remember to zero off our machine bed. Now the first thing we're going to do once we get done cutting the front of our chest piece is remove it from the machine, and then we need to go ahead and cut the dowel holes into our spoil board. And then from there we can go ahead and put our dowels into those dowel holes and then turn over our part and push it down on those dowels, and it should be lined up perfectly to run the next set of tool paths. Just make sure that we secure it down with clamps or screws. So to do that, we're going to go over to our 2D view and we're going to select our dowel holes, and we're going to go over to our profile toolpath. So our setup for this one is going to be slightly different. So our start depth is going to be the thickness of our material, which is 1.75. Because our machine will actually go up to the top of our material, we need to tell it to go past that so that it will cut right into our spoil board. Now also, it's important to remember that your material block will not be on your machine at this time, so we can safely avoid this distance without any problems at all. So the rest of this is all going to stay exactly the same. We're going to use that 1/4 inch end mill. We're going to cut inside that lines, and we're just going to go ahead and call this dowel holes. And then we need to make sure that we don't forget that this should be in spoil board, and that will remind us to do that. Okay, and then we can calculate that. And it's going to tell us that we are going to exceed our material depth, but that's okay because we know that's going to happen, and we can just go ahead and click OK. And you'll see when we turn it up on its edge, that toolpath is going to start past the bottom of our block right into our spoil board. So that's perfect. Let's look straight down that again. And let's preview that visible toolpath. Now that really doesn't help very much because it looks like it's just cutting right through our block, but it just does reassure us that it's going to cut those holes where we expect it to. Okay, let's close this down. So again, once we cut those holes into our spoil board, we're going to plug them up with our dowels. We're going to take our material block, we're going to turn it over, and we're going to push our material block down on top of those dowels, and that way it will securely be put into place and it will line up correctly. Now again, you're going to have to affix this down to your machine either by using your clamp, screws, or double-sided tape, or whatever your method is. Now let's go ahead now and have a look at our roughing pass. So let's click there, and everything else is going to be exactly the same as we had before. We just need to make sure that we tell it what level we want it to get the machining limit boundary from, and that all looks great. And we'll just go ahead and delete that out of there, and we'll calculate that. And we can preview that visible toolpath, make sure that it looks right. That looks really good. So let's close that down, and let's go on and create our finishing pass. And again, everything else is going to be exactly the same, except for we just need to make sure that we choose that proper machining limit boundary, and we'll call this finishing. Delete that out of there, and we'll calculate that. We'll preview that visible toolpath, and you'll see that it looks really good. Now, one of the nice things about our software is we can actually preview both sides of our toolpath previews at the same time. So if we choose preview all sides, what we're going to get once it's done simulating all of our tooling is what this is going to look like pretty much when we take it off of our machine, with the exception of the dowel holes won't go all the way through because we're previewing that spoil board toolpath in there. It does look like it cuts all the way through, but it won't. But in the end, there we have it. And that's exactly what we want. We just need to cut those tabs. Now, if we'd like to see how thick those tabs are in the end before we actually go ahead and cut this, just to be sure they're strong enough to hold this in place, we can hold down our control key. And if we look down here in the bottom right-hand corner, as I run over the part, it's going to show me the thickness of that tab, which is just a little bit under 0.18 of an inch is what we expected when we designed those tabs on the front when we set up our job originally. Now, if you'd like to go ahead and save off this tooling to run on your CNC machine, then you might want to preview the Toolpath Savings Guide, which has all the information that you need in order to do that.